All right, so this is the lesson for writing equations and drawing graphs to model a real-world situation. Okay, let's get into an example. Hopefully you've downloaded these notes, printed them out if possible from Classroom. Okay. Number one says owners of a recreation area are filling a small pond with water. They are adding water at a rate of 35 liters per minute. Okay, there are 600 liters in the pond sorry, this got cut off, but it says to start with. Okay, let W represent the amount of water in the pond in liters, and T represents the number of minutes that water has been added. Write an equation relating, sorry, this got cut off again, W to T, and then graph your equation on the axes below. Okay, so what's going on here is you start with 600 liters in the pond. So before they start filling up the pond, there's 600 liters of water in there, and then it's 35 per minute. All right, so the question says write an equation relating W to T. So the W comes first. That means it's going to come first in our equation. So your equation is going to be W equals, well, we start with 600 liters, so 600 plus 35 per minute. Okay, and we call the number of minutes T. All right, so that's going to be plus 35T. All right. In order to graph it, we want to write in slope-intercept form. We're going to turn this around. W equals 35T plus 600. And by the way, don't let the W's and T's turn you off. W is the same thing as Y. Okay, it's just the dependent variable, and T is the same thing as X, the independent variable. All right. So this is our equation. That's the answer that would go in here. Now we need to draw the graph. Okay, so this is in slope-intercept form. You should recognize that the y-intercept, or in this case, it's not the y-intercept, it's the w-intercept, is 600, okay? So we're gonna put a point on 600, okay? And notice we're only dealing with the part of the plane where everything's positive. Why is that? Well, our variables here, you can't have negative liters of water, right? Liters of water must be positive, and the other variable is time, so you can't have negative time. Time has to be positive. That's why we only have this quadrant one of the plane. Okay, so next, after we have the intercept, we need the slope. The slope is rise over run, and that's going to be 35 over 1. Okay, so we're going to go up to 635, which is going to be like over here somewhere, and go across to 1. Now what you're going to have to do when you're actually doing this on ALEKS, you're going to have to use the point plot. Sorry, pencil broke. Tool. Okay, the point plot tool is over here. All it does is it lets you enter a point by writing down its coordinates. So the point we want here is 1, 635. Okay, so you just enter that in, and it would plot it for you because we can't go by 35s, right? On my graph, I just drew it approximately. Okay, then to finish, of course, we're going to connect. All right, that's it for number 1. Number 2, Sugar Sweet Company is going to transport its sugar to market. It will cost $6,075 to rent trucks, and it'll cost an additional $225 for each ton of sugar transported. Okay, so it pays the $675 once to rent trucks, and then $225 for each ton that it transports. Okay, C represents cost, and S represents the sugar in tons. Write an equation relating C to S, and then graph your equation using the axes below. Okay, again, this starts with C, so our equation is going to start with C. It says C to S, so we're going to start with C. Okay, so we pay the $6,075 once, so that's going to be $6,075. That doesn't depend on S, plus $225 for each sugar ton transported, so that's be plus $225 S. Okay. And of course, to graph, we want to switch it to slope-intercept form. So that's going to be C equals 225 S plus 6,075. Okay, that's the answer that would go in there. All right, so to graph, we need the intercept, the y-intercept, which is really the c-intercept over here. That's going to be the 6,075. Okay, so now there's a problem, right? We have 1,000, 2,000, 3,000, 4,000, etc. We want to plot 6,075, which would be like right over here. So I can do this with my pencil approximately, but when you do it online, you have to do it exactly. So again, you're going to use this point plot tool. Okay, and you're going to enter the coordinates. What are the coordinates of this point? Well, it's 0, 6,075. All right. So next, we're going to use the slope. Oops. Let's rise over run. Okay, and the slope of this is 225. Okay, so we want to go up 225. We're at 6,075, so we want to go up to 6,300. Okay, and then over 1. So 6,300 and over 1. Again, we can't just put this on the axes. We have to use the point plot tool. So we're going to plot the point 1, 6,300. Okay, how did I get 6,300? Well, we were at 6,075 over here. We had to go up because we know our rise is 225. So 6,075 plus 225 is 6,300 and then over 1. Okay, so we need the point 1, 6,300. All right, so again, you're going to use the point plot tool because you're not going to be able to just simply put it on the graph. Okay, and of course, we are going to connect to finish. All right, so the I don't want to say hardest part, but what's new in this is using the point plot tool because we're dealing with some not so nice numbers that we're not just gonna be able to simply put on the graph. Okay, so that takes care of this lesson. This is due on Tuesday, April 7th. Yeah, April 7th. And remember that I'm not going to be issuing extensions. It's very important that you keep up with your work while school is closed. If you're having a hard time with this and you want me to go over it more in depth with you, please schedule an appointment with me using the Google Calendar link that I put on Classroom.